Hello everyone. Do you know why Spring Framework is so popular among Java developers? Because it helps developers to write maintainable, scalable, object-oriented code using best practices. And while we talk about object-oriented code and best practices, we should mention design patterns. And in this video, we will look at what design patterns Spring Framework utilizes in its core. Let's get started. Design patterns divided into three main categories: creational, structural, and behavioral patterns. We will start with creational patterns, and the first one is Singleton. And the idea behind Singleton pattern is very simple. You shouldn't be able to create more than one instance of the class. And why it might be useful for us? Because we can reuse the same object over and over again. Why? Because it is resourceful. Like we don't have to create object every time to use the memory. And let's get started and see some examples. Like there are multiple blocks of the code is trying to access database and of course meaning the connection. And every block is trying to access database with their own connection, but it's not very efficient because creating a connection requires creating a new object every time. That's why we introduce a singleton pattern here and create one object, singleton object, and use it throughout our application, and multiple blocks of the code can access to that connection object and then can access to database. And that's easy. And in other places like configurations, logging, or file accessing, we can use a singleton pattern. And let's see first how singleton pattern is implemented in Java, then we will look at the Spring. First, let's look. We should have static private instance field that stores the object, single object, and the private constructor to avoid object creation. And we have single get instance method that returns single object. At first it checks if there is an object already. If no, we create new one. Otherwise, we return the same object we already created. And let's check. For example, get instance method should return same object. It doesn't matter how many times we call this get instance method, it should return same object in theory. But let's check in action. And we are creating two different objects actually using get instance, and they should be the same object. We checking using equals. Let's run the application. And it returned true because behind the skins these two objects are the same objects, because here we are returning the same object we created initially. Let's look where Spring utilized this pattern. Firstly, Spring beans. By default, all beans that's created in the Spring application, they are singleton by default, and Spring's application context as well. This class, this object is also created as singleton, and the Spring caches uses singleton pattern for optimization, and the Spring Boot's application run as well creates a singleton object. Let's see in action. So we are creating two components and one service, and we inject this singleton service in two different components. Here we're injecting, and here as well we are injecting. Now I want to check if these objects, like singleton service objects, are the same object throughout our components. Let's see. We are printing the hash code of this service class. So let's run the application, to see the results. As you see, we have two hash codes with the same number, because even though we are injecting in two different places, we are injecting that same singleton object, service object, and we are reusing it in our application. This is very convenient and resourceful. Now let's see prototype design pattern. The idea behind prototype design pattern is object can be able to clone itself, and why it might be useful for us. Like, for example, we need the exact copy of the object, and to create a new object we should copy all the fields to the new object, and it requires a lot of effort. And sometimes if there's some private fields in the object, we cannot copy that fields to the new object. That's why here prototype pattern helps us to create a clone of the object, basically. And in Spring framework, mainly it uses in the Spring beans, in the prototype scoped beans. And request and session scoped beans as well uses prototype pattern under the hood. And let's see first how it's implemented in Java. Then we will look at the Spring implementations. As we see, we need to implement clonable interface in Java. And here we are. We have our fields, and we have a constructor with all the fields, and now we have a clone method. And clone method returns the exact copy of the object, and that's basically prototype design pattern. And let's see how it works with the Spring. For example, we are creating one service, prototype service, and make sure that we make this scope as prototype. And we are injecting it in two different components. First component here, we are injecting using an object provider, and here in the second component we are injecting using an object provider as well. Why we are using object provider? Because we are injecting prototype scoped bean into the singleton scoped component. That's why we are using object provider to inject. And now we have a print method to print the hash code of the object. And in the singleton it was same, because singleton uses the same object throughout application. But in prototype we create a new object every time, new copy of the object every time. As you see, we are getting the object and printing its hash code here as well, in the component as well. And let's try to run the first Java implementation, and this example should return false because we are creating new objects using a clone method. Let's run first. False, because we have a two even we are calling this clone method, it's creating a new object every time. And let's run our Spring application to see if this prototype service is creating a new object whenever we inject into a new component. Let's run the Spring application. As you see, we have a prototype service, and a prototype service 2 has two different hash codes because we are creating two different objects. And they are the exact copy of prototype service object, which we have here. Next pattern is builder. Builder says that we should be able to create objects step by step. And why it might be useful? Because when we want to create complex objects, we cannot create them at first try, because we need to collect different parts of the object from different sources. And in this case, our constructor will be overloaded and it cannot handle like a collection logic. And sometimes we don't want a full object, like we should be able to create a partial object and fill it later in the steps. In these cases, builder pattern helps us. And let's see how it's implemented in Java. For example, we want to create a car object, and for example, some cars has 2 doors and some cars has 4, and some cars has a rear camera and some don't have. And the brand, model, and color is parameters which all cars have, but these parameters might not be available for other cars. And in this case, we should pass null values or empty values to the parameter to the constructor. But using a builder pattern, we can achieve this partial creation or the full creation of objects using a builder pattern. So how it works? We delegate object creation to the builder subclass. Okay, there's a car main class, and we have a builder subclass that actually creates the object. For example, here we pass all the parameters and fill each field one by one. For example, model, brand, we pass brand and assign it and return the object itself using a builder. And for all the fields we create such methods, and at the end we build the real object. So we are achieving partial creation of object, and we can create the object step by step. Let's see in action. For example, we have a main method and we are creating some Toyota Corolla car, and it has a rear camera and a color, and it has a, for example, door count is 4. And now we want to create some other car, for example, Ferrari model, some kind of model. But Ferrari might not include a rear camera. That's why we can skip this field instead of passing null value to the constructor, because we are using a builder pattern here. And even color we can skip. For example, maybe all the Ferraris are red, and we don't need to mention this color for each of them. And for example, door count is 2. Usually Ferraris have two doors, and that's why in these cases, like, we can use the builder pattern and achieve step-by-step object creation without extra nulls. So let's run the application to check if our objects are created. Yes, as you see, car Toyota has all the fields, and Ferrari has model and door count, but color and the rear camera null. So, and let's see where this pattern is used in Spring applications. In Spring Framework, builder pattern is heavily used. For example, in URI creation, we can create complex URIs using URI components builder, and we can use builder pattern in security, filter chains, and HTTP filters, and object mapper. We can create the object mapper object using object mapper builder, and we can configure the REST template using a REST template builder, and a web client and application context builder also is a utilize a builder pattern. Let's see what kind of classes use the builder pattern in Spring Framework. For example, REST template builder. We create the REST template object using a REST template builder, and it has so many configurations like root, URI, default header, connection, read timeout. But as you see, we are skipping so much other configurations as well. We can pass them whenever we need. For example, we can add them or we can skip them, and it's very helpful. And For example, here to create the object mapper object, we can use a Jackson object mapper builder, and we can configure this object mapper object, and we can skip other configuration as well. And the builder pattern is very useful, and it's heavily used in the Spring framework. And the last but not least from the Creational pattern is factory. And the factory pattern's name comes from the real-world factory, because it contains some object creation logic, and it hides object creation logic. And factory pattern usually creates different kinds of objects related to the same family. For example, here in this example, factory class contains some shapes, square, circle, and triangle objects. And whenever we want some kind of object, for example, here we need triangle object, and it actually generates a triangle object and gives it to us. And factory pattern is heavily used in Spring framework, and it's one of the core patterns, because let's see the Java implementation first, and we will back to the Spring. So, for example, we have a phone factory somewhere in China, and client says they need some Android and iOS phones, but they don't know how Android and iOS phones are created. They don't have any idea how these phones are produced in the factory. But yeah, they are all phone, but we should be able to handle it in the logic as well. We will have one factory class that actually generates objects based on some parameter. For example, if we need Android, it will generate a new Android phone, and if user passes iOS parameter, it should generate iOS object. And we should have some interface to group all the objects into one family. For example, we are interested in the phone objects. And Android phone, iOS phone, and so they all implement phone methods. Or write some phone methods called message browse. And we actual logic is inside this phone factory, where we get the phone using some kind of type. Let's see how we use the factory in the code. Like we use the static get method, get phone. For example, in our specific example, phone factory dot get phone using our parameter Android, and it will generate Android phone. And in the next object is the iOS object. We send some parameter, and it will create iOS object. Let's see if our objects is really Android and iOS objects, because they use the same interface, and we are using the same method but with different parameters. Let's run. As you see, calling from Android phone, calling from iOS phone. We have mentioned it here, calling from iOS phone and calling from Android phone. So, let's see where factory pattern is used in Spring framework. Bin factory. Bin factory is the core of Spring framework, and the application context also implements the bin factory as well. And the JDBC templates use the factory pattern. And transaction manager factory that generates transactions, and proxy factory where we use the proxy factory in AOP. Let's see one example how this application context works. For example, we have a application context class object, and we have a getBin method. And getBin method actually takes a parameter, and in this case some type, some component type, and generates actual object from the type using a getBean method. And under the hood, application context uses the factory pattern. And we have some components here, as you see. And let's see if the application context uses factory. As you see, it extends from listable bin factory and hierarchical bin factory. Let's open listable bin factory. It is extending from bin factory. And all in all, application context extends from bin factory, and the bin factory uses factory pattern. If you look at the implementation, for example, static listable bin factory. As you see, it will take the type, name, for example, and creates actual bin in the code. And with this, our lesson is over with the creational patterns, and see you then in the next upcoming structural patterns sessions. Bye.